Hello, and welcome to this video on synthetic division of polynomials. Um, Synthetic division is very algorithmic. It's best done by demonstration. The steps are a little hard to describe in words, but they're very easy to follow with examples, so I'll do 3 examples in this video. So what is synthetic division? It's a substitution for polynomial long division when the divisor is a binomial of the form x minus a. Okay? So consider if we were going to divide the expression 2x squared plus 9x plus 10 by x plus 2. Okay, so I just did this polynomial long division out, and you see that what we wind up getting when we divide 2x squared plus 9x plus 10 by x plus 2 is in fact 2x plus 5. Okay, so how do we come up and get this 2x plus 5 by using what's called synthetic division? Okay, so I'll model that here now. Okay, well, you notice here it says that the binomial you're dividing by is the form x minus a. So what we have here is that this needs to be rewritten, or at least reread, as x minus negative 2. So a equals negative 2. Well, I'm going to take that value of negative 2 and write it here. I'm just going to put this little hook around it, symbolizing I'm going to do synthetic division. Okay? And then what I'm going to do is I'm just going to take the coefficients, okay, the constants as well in this expression, and I'll set them up here just in a row, 2, 9, and 10. Okay? Then I'm going to leave a little space and draw a line. Now this is where the magic starts. Okay, so try to follow this. First thing you do is pull down the 2 below the line here. Then I'm going to multiply the negative 2 by the 2 and write the answer right here. So it's going to give me negative 4. Okay? Then I'm going to add down. 9 plus negative 4 is 5. And again, I'm going to take my value of a, multiply it by that number, and write the result here. Sometimes we refer to this as bounce multiplication. So that will give me negative 2 times 5 is negative 10. And then I will add down here, and you'll see that I get 0. Okay? Now, this last digit in this bottom row, this represents the remainder. Okay? So we see the remainder is 0, and that makes sense because when I did the polynomial long division, I didn't get a remainder. Now you can probably see what I'm going to do with the 2 and the 5. If you notice here, we see that the expression, the polynomial expression that we started with, was of degree 2. Okay? So we can use these constants as the coefficients for the answer, and when we divide it by a linear term, it would make sense to decrease this degree of 2 by 1, because you divide it by a linear term. So that means that this first term in the answer will be linear. This will be 2x plus 5. And that is the answer. Again, same answers I would get through polynomial long division, just much quicker. It's a really cool method. It's a shorthand for it, almost somewhat abbreviated. And let's do a couple more examples. Okay? So, if you see here, consider we're going to divide 2x cubed plus 3x squared minus 44x minus 105 by x minus 1. And again, you see here that I have the polynomial long division done out. Okay? And in green, I have the answer here. If you notice, it's 2x squared plus 5x minus 39 minus 144 over x minus 1. Well, you'll probably see that's because the remainder here when I divided was negative 144. So I create a fraction of making negative 144 over x minus 1. So this, in fact, is a polynomial long division with a remainder. So we'll see how we get a remainder when we do synthetic division. Okay? So we're dividing by a binomial of the form x minus a. So we see that a is just equal to 1. So I'll set up my 1 with a little right angle around it, just kind of a common way of writing it. Then I'll use the coefficients of 2, 3, negative 44, and negative 105. Okay? Kind of skip a line, draw a line. Okay? And then I'm going to pull down my first number. You can also think of this as having a 0 here, and again, adding down. Okay? Either or works fine. So I'm going to get 2. Then I'm going to do 1 times 2 to bounce multiply, and get 2 here. Then I'm going to add down and get 5. And then I'm going to do 1 times 5, and that'll give me 5. Doing that little bounce multiply step. Now I'm going to add down and get negative 39. And again, I'm going to multiply 1 by that result and get negative 139. And then when I add down, we are going to get 144, but negative. Again, the last digit is the remainder. And because you're always dividing by a linear term when you're doing, or a linear expression when you're doing synthetic division, it will decrease the degree of the expression dividing by 1. So I'm going to go from cubed to squared, and then you'll see that I will write 2 is my coefficient of my x squared term, plus 5, my coefficient of my linear term, minus 39 is the constant, and then the remainder of negative 144 over the original expression of x minus 1. And you in fact see that's the same answer I would have gotten by polynomial long division. Okay, I'm going to do one more example here. And this example is got a little twist in it here, okay? One of the things that's important in polynomial long division as well as synthetic division is that when you, in fact, write your term that you're dividing, it has to be in descending order, okay? So if we see in this example here, we've got 4x to the fourth, 12x cubed, minus x minus 3. Well, there's no quadratic term here between the cubic term and the linear term, okay? So I needed to insert that when I was doing the polynomial long division so that I've got descending order again. Okay, so it went 4x to the fourth plus 12x to the third plus 0x squared minus x to the first, and then minus 3x to the 0. Okay? So now this is the appropriate way to write an expression that you're dividing when doing polynomial long division. It'll be the same for synthetic division. So when I do it out, you see that I get 4x cubed minus 1 is my answer. There was no remainder here in the end. So let's see what that looks like in synthetic division. Again, I'm dividing by something of the form x minus a, so this will be x minus negative 3, a equals negative 3. So I'll set up my negative 3, the little hook around it. Now my first coefficient for the quartic term, the fourth degree term, is 4. And then the next one is a 12 for the cubic term. And then you see there is no quadratic term, so I'm going to put a 0 in, because you saw here that there's a 0x squared. Then I'm going to put in for the linear term negative 1, and for the constant it's negative 3. So skip a line, draw a line, and then we'll just get to work with pulling this 4 down. We're adding through an invisible 0, get 4. Negative 3 times 4 when I do my little bounce multiply step is going to be negative 12. And then when I add down, I get 0. Then when I bounce multiply the negative 3 times the 0, I in fact get another 0. When I add down, I get 0. And now when I bounce multiply the negative 3 times the 0, I will in fact get 0. And when I add down, I'm going to get -1, and then I'm going to bounce multiply the -3 times the -1, and get 3. Then when I add down, I get 0, and we see that my remainder is 0, which was consistent with my answer when I did the polynomial long division. Again, I'm dividing by a linear term. I started with a quartic expression, so it'll depress 1 degree down to a cubic. So I'll get 4x cubed plus 0x squared plus 0x minus 1. Then cleaning that up, we can see we don't need to represent the quadratic or the linear terms. So I will get 4x cubed minus 1. And that is my answer, same answer as I would be getting as if I did polynomial long division. A lot easier to handle this way too. So, in conclusion, what do we want to kind of realize here? When you're doing the synthetic division, you're going to need to make sure that the binomial is written as a difference. So you need to have that x minus a form. When you establish a, you're going to write it over here in the margin. Okay? Then you're going to write all of your coefficients in descending order, making sure to insert zeros for any missing terms so that they're all represented. Then you'll start to pull down the first term, bounce multiply, add down, bounce multiply, add down, bounce multiply, add down, and then in fact the last number you get represents the remainder. Okay? Sometimes the remainder is 0, and like we saw in this example, sometimes it is not. In my next video I'm going to do, you're going to see how that relates to some numbers theory ideas of what it means to get a remainder or not when you are dividing polynomial expressions. So I hope this was helpful. Feel free to watch again. Practice hard.